Hello student, in this video we will learn one of the type of mechanical sensor, that is strain gauge. From this video the student will be able to understand what is a strain gauge, principle of operation of strain gauge, its different type, working of strain gauge, advantages, disadvantages and applications of strain gauge. Now let us define what is strain gauge. Strain gauge is a passive type of sensor whose resistance varies with the applied force. We know the definition of passive type of sensors are those sensors which will work on the external power supply. Now when the force is applied to the strain gauge, that time either mechanical elongation or compression takes place. Again this mechanical elongation or compression will be converted into change in the resistance. This change in the resistance takes place due to the variation in the length and the cross-sectional area of the gauge wire when an external force acts on it. That means the strain gauge converts a force, pressure, weight, this quantity into change in the electrical resistance which can then be measured. Now we will see one of the important characteristics of the strain gauge, that is nothing but sensitivity or gauge factor. The gauge factor is defined as unit change in the resistance per unit change in the length of the strain gauge wire. This is a mathematical representation of the gauge factor, where this R is the resistance of the gauge wire in ohm, this dR is the change in the resistance of wire in ohm, this L is the length of gauge wire in unstressed condition in meter, this dL is the change in the length of the wire when stressed in meter. Now we will see the principle of operation of strain gauge. When the force is applied on the strain gauge, that time the strain gauge either compress or it will expand. That means its dimension L or A will change. Now we know the relation between R, L and A, that is R is equal to rho L by A. With this equation, due to change in the dimension when the force is applied, that time change in the dimension will result into change in the resistance. Now look at this diagram for the strain gauge. Under compression, the resistance goes down, whereas in this diagram, when the strain gauge under tension, the resistance goes up. Now we will see the different types of strain gauge. The strain gauge are mainly divided into two types, that is wire gauge and semiconductor gauge. Wire gauge is again divided into three types, that is unbounded, bounded and foil type. Now we will see the first type of the strain gauge, that is unbounded wire strain gauge. It is called as unbounded as the wire is not completely bounded with the carrier. It consists of a fixed body of the fixed frame and one movable part. An unbounded strain gauge consists of a wire stitched between the 2 points in an insulating media. Now, when the force is applied to the structure, because of this movable armature, these wires will change its dimension. These strain gauge wires are connected in the Wheatstone bridge circuit. When the no load is applied, the bridge is balanced. Now when an external load is applied, the resistance of strain gauge changes, causing unbalance, resulting in the output voltage that is proportional to the strain. The application of this unbounded wire strain gauge is used in the removable gauges, also to measure the different quantities like force, pressure, acceleration. It is having a high accuracy but more space is occupied. Now see the second type of the strain gauge, that is bounded. In case of bounded strain gauge, the metal wire is bounded to the carrier with the epoxy. In case of bounded strain gauge, the resistive element is cemented to the base, which may be a thin sheet of paper or a thin sheet of bakelite or sheet of Teflon. The resistive element may be in the form of wire, foil or the film of the material. The application of the strain gauge are It is inexpensive, small, temperature dependency is less. It is very sensitive to the static and dynamic load. It is also having a disadvantage that as it is directly bonded to the specimen or due to wear of the adhesive will reduce its accuracy. The next type is foil strain gauge. It is formed by rolling out a thin foil of the resistive material and then cutting away the parts of the foil by a photo etching process to create a required grid. In this strain gauge, the strain gauge is measured using the metal foil. As it is having a larger surface area, the foil gauges have much greater dissipation capacity. Therefore, they can be used at the higher operating temperature range. There are so many advantages, that is, it is more flexible, good sensitivity, perfect bonding of the strain gauge is easily possible. They can be fabricated on the large scale and in any shape. Another type of strain gauge, that is semiconductor strain gauge. If a metal conductor is stretched or compressed, its resistance changes due to change in its length and diameter. Similarly, there is a change in the value of the resistivity of a semiconductor when it is strained. This property is called as a piezoresistivity. The semiconductor strain gauge operates on the piezoresistive property of doped silicon and germanium. Such type of strain gauge are fabricated from the single crystal of the silicon and germanium. So simply, the resistance of the semiconductor gauge changes mainly due to the change in the resistivity of the semiconductor material itself. Now we will see the working of the strain gauge. In order to use the strain gauge as a practical instrument, we must measure extremely small changes in its resistance with the high accuracy. This can be achieved by using a bridge circuit as shown in this figure. The output voltage is proportional to the amount of the stress. Now when the force or the pressure is applied, that time the strain gauge, it will either compress or expand. Because of that, again it will change in its resistance, and this change in the resistance will be converted into voltage with the Wheatstone bridge circuit arrangement. Here only one strain gauge is connected in the Wheatstone bridge circuit, but in practical application a single strain gauge is generally not used. Instead, either 2 or sometimes 4 strain gauges are connected in the bridge circuit. The advantages of the strain gauge are: the change in the resistance is much higher than that of the conventional metal alloys types. It is having high gauge factor. Also, it is in the small size. Along with this, there are few disadvantages, like its linearity is very much poor, and it is more expensive, and its sensitivity to the change in the temperature. There are so many applications of the strain gauge. The main application, we can use it in pressure measurement and weight measurement system. Thus the strain gauge is called as a mechanical sensor, as the mechanical quantity like force, pressure are converted into change in the resistance.